All right, this is Note Taking Guide 6.6 for Math 1. So we're going to continue in our geometry unit here and talk about some two-dimensional figures and some of their properties. So the very first thing we're going to do is we're going to learn to name a polygon by its sides. If you remember, like a four-sided figure is a quadrilateral, a five-sided figure is a pentagon, those kinds of things. Then we're going to classify it as convex or concave, and regular or irregular. So here's my two that show me convex and concave, and here's my two that show me regular or irregular. So what's the difference between convex and concave? When you're looking at this, can you see a difference between the two shapes? I like to remember concave because when it's concave, one of the sides or more than one of the sides have to cave in, meaning kind of point in towards the shape. Where convex, all of the sides go outward or are kind of straight. So that's the difference between convex and concave. And then regular and irregular. Regular shapes have the same measure on every side, meaning all of these sides have to be equal to each other. The same thing is true of their angles. All angles have to be equal to each other. So every single one of these angles measures the exact same. So to be regular, all of your sides have to be equal to each other and all of your angles have to be equal to each other. And irregular means exactly the opposite. The sides and the angles are not equal to each other. So anything kind of goes to be irregular. Alright, so what we're going to do is we're going to take a look at these next shapes. We're going to name them by their sides and then say whether or not they're concave or convex, and then we're going to say whether or not they're regular or irregular. So this has 1, 2, 3 sides. 3 sides, we know the name for that. That's actually a triangle. Convex or concave, well, nothing caves inward, so we're going to go with convex. And regular or irregular, well, it's marked not equal, which means it's automatically going to be irregular. If they're not equal to each other, they're irregular. All right, next problem. This time we're just going to count sides. This is 1, 2, 3, 4, 5-sided figure. I actually know the name of a 5-sided figure, if you can remember what that is. 5 sides is a pentagon. And then we're going to decide convex or concave. Well, nothing's caving in, so we're going to go with convex on that one. And regular or irregular, you can tell the sides don't measure the same length. So this one's going to be irregular. Okay. Next one, let's take a look at one more here. Let's count the sides. 1, 2, 3, 4, 5, 6 sides. A 6-sided figure is called a hexagon. This is actually concave this time because it's got a side caving inward. And then no sides look like they're equal to each other, so this is also going to be irregular. So we didn't have any regular ones this time, but that's alright, we're going to find one eventually. Alright, the next part says identify the shape of each traffic sign and classify is it regular or irregular. So the shape, 1 side, 2 side, 3 sides, 4 side, 5 sides. So this is a pentagon. And regular or irregular, I gotta go with irregular because none of the sides measure the same. You got this short little guy over here, and then you have this long guy. Okay, next one. Count your sides, 1, 2, 3. So this is a triangle because it has 3 sides. Triangle, I'm going to say it's probably regular. I think that this side looks like it equals this side and this side. And then I think the angles look like they're pretty close too. So I'm going to go with regular on this one. It's definitely the closest thing we've seen to regular so far. And then our very last sign, this has 1, 2, 3, 4 sides. 4 sides are called quadrilaterals. And then I'm going to go with irregular because you got this short little side and then you have this really long side over here, so not going to be irregular. All right, so that's taking a look at how we're going to classify our polygons today. So let's go and actually do some math now. So this says find the perimeter or circumference and then find the area. So this one's definitely a perimeter because the only time we find circumference is on a circle. So I'm going to just make sure that I have all of my sides marked. So I know that 150 is this side from here to here. I know 110 is this side from here to here. I know 225 is from here to here. And I know that 80 is from here to here, but I'm missing this piece right here. So how could I figure out how long this piece is? Well, I know that this length from here to here is 110. The whole length is 225, which tells me that this side right here is going to be 115, because if I do 225 minus 110, I get 115. Then likewise, I have to find this piece right here. I know that the whole length across here is 150. So if I know that this piece right here is 80, then I can go 150 minus 80 and I can get 70 for this length right here. So now that I know all of those pieces around the outside, I can add them all together to get my perimeter. So, I mean, I don't think I'm going to take the time to write that out because I'd have to write 110 plus 150 plus 225 plus 80 plus 115 plus 70. Let's just punch those in our calculator all the way around the outside, and that will give us our perimeter. So 110 plus 150 plus 225 plus 80 plus 115 plus 70 is 740. So the perimeter of this is 740 feet. Then I still have to find the area because it said I needed to do both. So area, on the other hand, is the measurement of the inside of something. So I actually have two rectangles here that I could find the area of and then add those two rectangles together. Adding those two rectangles together would give me the area of the whole thing. So I know that my area formula is length times width on this. So my length of this is pretty clear. It's 150. And then times by 110. So that's going to give me the area of this one. Then I got to do the area of this little guy over here. So I'm going to go, the length is 115 times the width, which is 80. And if I add those two together, then I'm going to get the area of the whole thing. So first do 150 times 110, and I get 16500. And then do 115 times 80, and I get 9,200. Add those two numbers together, and the area is actually 25,700 feet squared, because areas are squared. All right, that was a little bit of work, but let's take a look at our next problem and see what we've got there. So this one's definitely a circle. So circumference, if you remember, the formula for circumference is 2 times pi times r. So really all we have to do is find our radius, and we can do the circumference formula on our calculator. The radius of this was given to you. It's 4 because the radius goes from the center to the outside edge of the circle. So we really just have to punch that into our calculator. There's a pi key on your calculator even, you guys, so just punch in that pi key on your calculator. When you punch that in your calculator, it's going to tell you that the answer is 8 pi, which is the correct answer if we want it exact. But if you hit those double arrows above the enter sign, it will change it to a decimal point number for you. So 25.13 centimeters is the circumference. Then just a reminder on the area formula for a circle. The area formula is pi r squared. So again, all you have to do is substitute that radius value into your formula. On your calculator, do pi, do 4 squared, and just punch it in just like that. When you do that, your calculator is going to tell you the answer is 16 pi. And again, if you hit those double arrows at the bottom, it will change it to a decimal point number for you, which is 50.27. If we're rounding, this would be centimeters squared because it is an area. All right, next problem. This time we're doing a triangle. So perimeter is pretty easy of a triangle. We're just going to add these outside edges together. So 9, 12, and 5. So 9 plus 12 plus 5 That gives me a perimeter of 26. So that was simple enough. So then we're going to find the area. The area formula for a triangle is 1/2 the base times the height. So we're going to have to go 1/2 base and height. The base and the height always form a right angle together. So our base is going to be 12 and our height is going to be 4. And then we just plug that in the calculator. And our area for that is going to be 24. And then this would be units squared. This one up here is just units because we don't know a measurement on this. All right, one more problem I think is what we have left to do here. This one says find the perimeter and the area of triangle ABC that has vertices of -1, 4, 1, 1, and 2, 4. So the very first thing I'm going to do is I'm going to graph those ordered pairs. The first one was -1, 4. So go over -1 and up 4. Put your ordered pair there. That was ordered pair A up here. Then we're going to do B, which is 1, 1. And then we're going to do C, which is 2, 4. So right here. So my triangle actually comes through those ordered pairs like this. Now you guys, in order to find the perimeter or the area of this, I actually have quite a bit of work to do because I got to find the distances between these points right here. So I'm going to have to put all of those through the distance formula in order to do that. So the first distance I'm going to find, so this was point B down here, I'm going to find distance AC. So really what I'm going to do is I'm going to use my A ordered pair, which is -1, 4, and my C ordered pair, which is 2, 4. And I'm going to put that through the distance formula. So one thing I'm going to do then is I have to repeatedly use that distance formula here. I'm going to have to use it 3 times. So I'm just going to write it over here and remind you what it is. So the distance formula is that big square root formula where we're going to have to go x2 minus x1 squared plus y2 minus y1 squared. So we're going to be putting through that distance formula these numbers, and then we'll go from there. All right, so I changed that color hoping I could see it better over there. I thought it would let me write over on more space, but it didn't. So, all right, so I'm going to put these numbers through that distance formula. I'm probably going to have to erase here in a minute because I'm going to run out of space. Actually, maybe I should move over a little bit to do that, but so x2 minus x1, so I'm going to go 2 minus a -1, I'm going to square that, and then I'm going to do y2 minus y1, so 4 minus 4 squared. So this actually adds to be 3. 3 squared is 9. This adds to be 0, and so 0 is 0. So my actual distance from A to C is 3. So this is going to be nice. Okay, so my writing is really bad because I'm trying to write too small. So I'm going to see if I can't step my game up a little bit here and see if I can get my writing a little bit bigger for you. Okay, so let's do, that was from A to C. So let's do from C to B. So let's go C to B. So C's ordered pair is 2, 4, and B's ordered pair is 1, 1. So let's plug that through the distance formula and see what we get. So distance formula says x2, so 1 minus 2 squared plus 1 minus 4 squared. And I'm just going to plug that through my calculator. This is going to be a -1 squared, which is 1. This is going to be a -3 squared, which is 9. So that's going to be the square root of 10. And I was going to get a decimal point number for that. So the square root of 10 is like 3.16. So 3.16 is from B to C. So we're coming over here with 3.16. Okay. All right, I'm going to erase my work here for that so that I have some more space to work. And I've been writing my answers over there on the other side, so I should be good. Okay, now I'm finding the distance from A to C. So A's ordered pair is -1, 4, and C's ordered pair is 2, 4, and I'm plugging it through the distance formula. So I go 2 minus -1, which is a plus, squared, plus 4 minus 4 squared. So that one's gone because that's going to be 0. This is going to be 3 squared again, which is 9. And 9 square rooted is going to be 3. So this length over here is going to be 3. All right, you guys, before we go on a little bit, I'm going to change this value over to 3.6. When I calculated wrong, I punched something in my calculator wrong. So I just was looking at that and I'm like, that is a funny number. So anyways, I went back and I recalculated with the video on pause, and that value is 3.6. Something just went funky when we were doing it. So sorry about that. Change that to 3.6 and let's finish this. So the perimeter of this triangle that we have graphed over here is going to be all of those values added together. So the perimeter is 3 plus 3 plus 3.6. which is going to be 9.6. The area, on the other hand, we have to go 1/2 the base times the height. So the base of the triangle and the height of the triangle form a right angle together. So I'm going to take this and I'm going to draw my height from here to here. And the reason I'm going to do that is I can actually count that height because it goes straight through the line. So 1, 2, 3. So my height is also 3. My base is going to be 3. So 1/2 of 3 times 3, which is going to be 4.5 for my area. So these kinds of problems are a lot of work, you guys, but be very accurate on your distance formula. Like you could see, I was trying to go fast. I punched something in my calculator wrong, got a little bit off. If that happens, you guys, and you're doing the process right, I'm obviously going to give you most of the credit for that just because there's so much work associated with these. Anyways, come and see me at my desk if you have some problems, and good luck with your homework.